side by side within a single setup. The complete robotization of the process allows for the surgery to be performed in an environment with varying temperature and pressure. The procedure begins by preparing the donor and recipient bodies. The donor is a brain-dead patient who has a functional body with vital organs in good condition, while the recipient is the patient whose head will be transplanted onto the new body. General anesthesia is administered to both the recipient and the donor. Both patients undergo tracheotomy, with a tube inserted into the trachea to provide respiratory support and facilitate mechanical ventilation. Our proprietary artificial plasma solution is administered to both the recipient and the donor. This solution is designed to keep the brain and body oxygenated, prevent clotting, and allow for safe operation at low temperatures. The recipient's head and the donor body are cooled to approximately 5 degrees Celsius to reduce potential brain damage during the detachment. Guided by advanced real-time molecular-level imaging systems, BrainBridge carefully separates the heads from the two bodies with the help of a specialized surgical technique that preserves the spinal cord and key blood vessels. Deep incisions are carefully made around the neck to expose the necessary structures, including the carotid and vertebral arteries, jugular veins, and spine. With the help of specialized AI algorithms, BrainBridge tracks both muscles and nerves during surgery to facilitate seamless reattachment. Next, incisions are made in the trachea, esophagus, veins, and arteries. The blood is then completely drained from the recipient's head to prevent clotting. The recipient's head is then positioned adjacent to the donated body using a mobile platform. BrainBridge immediately connects the detached head to the circulatory system of the donor body, which helps maintain blood flow during the rest of the procedure. It also re-warms the recipient's head and provides it with oxygenated blood. With the help of its ultra-precision surgical instruments, BrainBridge begins reconnecting the spinal cord, esophagus, trachea, nerves, blood vessels, and other tissues. This step facilitates communication between the brain and the new body. The machine utilizes microsurgery techniques and delicate microscopic adjustments to ensure the proper alignment and fusion of the spinal cord and other tissues. To help reconnect the severed neurons, BrainBridge uses a proprietary chemical adhesive, polyethylene glycol, which is applied locally to the spine at the point of fusion. Once the spinal cord is connected, a specialized implant is placed in the epidural space behind the spine over the point of fusion. This implant promotes the repair of damaged neurons and allows the patient's brain to form neural connections with the new body and ensures that the sensory system is restored.